Assalamualaikum guys, my name is Danish Haikal. So today we want to discuss about a past year question. So question 1, figure 1 shows the mass spectrum of element BB. Calculate the relative atomic mass of BB. So if you want to calculate relative atomic mass, you must multiple mass or charge with intensity, percentage of intensity. So after that we divide it with 100, we will get the answer 55.91 AMU. Don't forget SI unit. Okay, so this is the question answer. So we must transfer it. So AR of BB equal to 55.91 AMU divided with 1 per 12 multiple with 12 AMU, and we will get the answer 55.91. So this is the way to find the relative atomic mass. So question B, what is the empirical formula of ibuprofen? So based on the question, it give the many information. So first and foremost, we must find the mole of CO2. So if you want to find the mole, we must use the formula mass divided with molar mass. So we use it to find mole of CO2, H2O, and hydrogen and carbon. So for CO2 we get 0.315 mole. So for H2O we get 0.218. For hydrogen we get 0.436 mole, and for high carbon we get 0.315 mole. So after we get mole for each element, we can get the mass for carbon, hydrogen, oxygen. So for mass of carbon we get 3.783 gram. For hydrogen we get 0.436 gram, and for oxygen we get 0.772 gram. So after we get all of this, we can get mole of oxygen from the mass of oxygen. So we can get the answer 0.048 mole. So we must do a ratio of mole, and then we will get for carbon we get 7, oxygen we get 1, and H we get 9. So the empirical formula is C7H9O. So this is the final answer. So for question C1, so the question 1, the percentage of by mass of CaCl2. So we must use the formula mass of solute divided with mass of solution multiplied with 100. So we will get the answer. So we can get the information from the question. So we will get the answer 20%. Okay. How I get it from the question, it mentioned the mass of CaCl2 16 gram, and mass of water 64 gram. So if you for solute, we just pick mass of CaCl2, and for solution we must the mass of CaCl2 plus with mass of water. So this is how I get. So for question 2, molarity, one molarity of CaCl2 solution. So the formula we must use moles of solute divided with volume of solution. So we must find first moles of CaCl2, and we get 0.193. So the information from the question. So after we get the moles, we must find the volume. So the volume of solution we can get from the formula of density. Density equal to mass divided with volume. So density, it was mentioned that is 1.18 equal mass 64 plus 16 divided with volume. So we can get the volume 67.8 ml. So we can get the molarity 0.9193 divided with 67.80 equal to 2.847 multiplied with 10 power minus 3 mol dm minus 3. So don't forget the SI unit. So for question D, it on the limiting rate, it want the limiting reagent in the reaction. So first thing we must do is find the moles of aluminium. So the formula for moles is mass divided with molar mass. So mass is 0.355 divided with 26.98. We can get the moles of aluminium is 0.01315 mole. So we get the answer. So use the same formula for HCl and we will get the answer 0.08000 mole. So after we get the mole, no. For most of HCl, we use the answer for we use the formula MV divided with 100 for mole. So we will get the answer is 0.0800 mole because the question give the volume for HCl. Is it correct? Yes. Okay. So we get the mole for AL and HCl. So we can use the ratio. So or stoichiometry. So we want find the mole of HCl. So 0.01315 mole aluminium equal to 0.01315 mole aluminium divided with 1 mole multiplied with 3 mole HCl. So we get the mole for HCl that is needed is 0.3945 mole. So since 0.0800 mole that's given is over or more than mole needed that is 0.03945, HCl is in excess reagent. So aluminium is the limiting reagent. Okay, so you guys understand. So for question 2, so if the percentage yield of hydrogen is 85%, calculate the actual mass of hydrogen obtained. So it want the actual mass of hydrogen obtained. So we must find the moles of H2 first. So use the formula for mole. Then we will get the answer is 0.019725 mole H2. Okay. By the way, refer to the stoichiometry. 3 mole Al equal to 2 mole H2. Okay, and then we can get the theoretical mass of H2 that's equal to moles multiplied with molar mass. So from the question, from the answer that we get, 0.019725 mole multiplied with molar mass for H2 2.0 g per mole, we can get the answer 0.03945 gram. So after we get the theoretical mass, we can get the actual mass of hydrogen. So the formula for actual mass is theoretical mass multiplied with percentage yield divided with 100. With 100. So after use the theoretical mass 0.03945 gram multiplied with percentage yield 85 divided with 100. That's we refer to the question, and then we will get the answer for actual mass of hydrogen is 0.0335325 gram. So lastly, don't forget SI unit. So I just want to give a tip. If we do all the question, don't forget SI unit.